So now we're going to start having a look at the probability section of our notes. Now the probability section is quite large, so it's going to be split into several videos. The first video that we're looking at is going to be looking through notation and how to handle probability using a two-way table. So first of all, looking at notation, we have probability of A and probability of B. PA, PB represents the probabilities of events A and B happening. So PA is how we would write down the probability of event A happening. PB would be the probability of event B happening. If we have PA dash, that means the probability that A does not happen, and we can find this by doing 1 minus the probability of A. If we have the probability of A and B like this, with this upside down U shape, then that's the probability of A and B happening together. It's also called the intersection of A and B. For AUB, written like this, this is the probability of at least one of A and B happening. Another way of thinking of that is that it's the probability of A or B or both. And this is a little bit different to how we think about the word or in real life, okay? The reason for that being is that if you were to offer someone a cup of coffee or tea, you wouldn't expect them to then say both, okay? So it's got that extra clause on the end of it, so it's not actually the way that we use the word or in real life, it's just the way that it meant in probability. So that's really important that we understand that when we've got this union symbol, it's meaning A or B or both of them together, not just A or B as we would use the word or in real life. Now the next one, this symbol here, this straight down line thing, means A happens given that we know the event B has happened. So it said it's the way that we'd read this out is the probability of A given B. So the probability of A happening given that we already know that B is true. And this is what we call conditional probability. We will have a look at it in a bit more detail when we get onto the Venn diagram section as well. So that's it for notation for now. We're going to move on to having a look at two-way tables. So a two-way table, you should have seen these at GCSE, and they're a way to represent two different events which outcomes can happen together, separately, or not at all. If we know that an article has a type B defect and that the probability that it also has a type A defect, then this is an example of a conditional probability. So there are articles with type B defects, of which so many of them will have a type A defect. So this probability is usually expressed in one of two ways. What is the probability that an article of type A defect, given that it has a type B defect, or written the other way around, given that the article has a type B defect, what's the probability that it has a type A defect? But both of those are meaning this here, which we were just talking about, the conditional probability. So we're going to have a look through some questions using two-way tables. So here is our two-way table. This is representing students in the first year of a science course at university take an optional language module. The number of students in each gender choosing each available language is shown. So here we have our different genders, male and female, and across the top we have our different languages, French, German and Russian. Now it's helpful that we have the totals as well, because this is going to help us to choose our probabilities. So we've also been told a little bit of notation to use. So M is going to represent males. So if I'm talking about the probability of M, that is the probability that someone is male. So the way that we would describe female would be the probability that they are not male, written with the M dash, and that's going to represent females. We have R is the event that someone studies Russian. So if we have probability of R, that's going to be the probability of someone studying Russian. Okay, so now we're trying to find the probability R intersect M. So if I go back, R and M means that we're looking Russian and male, which was representing these 14 people here. So that's 14 people out of our total of 70 people. So that's our probability, 14 out of 70. For the second question, male union Russian, that's male or Russian or both, remember. So if we go back, that means that we're looking at male, so going across here, or Russian. Now we have to be careful here because we can see that this 14 here is being counted twice. That 14 counts for the males and it's counted again for the Russian. So when we're trying to calculate how many people that is in total, we can't just do 40 add 21 because that's going to include these 14 people here twice. So we need to think of it as 17 plus 9 plus 14 plus 7, which should give us 47, again out of our total of 70 people. So that's our probability, 47 out of 70. Next, we're looking at the probability that the student is a male given that they are studying German. Now, the way that we would write this using the probability notation would be P, M, given, so straight down line, that they're studying German. Now, we've not been told what symbols to use for German or for French in the next question, but considering they gave R to Russian, it's a good idea that they'd give G to German. We can't just say not Russian, as we did with not males to represent females, because there are two languages that are not Russian, so that isn't being clear enough. So remember, we were looking at male given German. So at the beginning of this, I'm just going to rub out a bit of my highlighted sections just to make it a bit clearer what we're looking at now. So we're looking at German. So this is the only section that we are now pretending exists. So we're just looking out of these 20 people here, how many of them are male? So that is 9 people out of the 20 that study German. And that's going to be our probability. We're no longer looking at the entire population. We're just looking at those that study German. So that's 9 out of 20. For the probability that student is female, given that they are studying French, so that's going to be the probability of not male, given that they are studying French. And again, just as we did last time with the German, this time we're only going to be looking at French. So if we just highlight our French column, remember we're only pretending that these people now exist. We're ignoring the rest of our table. We're just looking at this section here. And we want female, given that they study French. So we're looking at those 12 people there. So that's 12 out of the 29 people that study French. So that's going to be 12 out of 29. Just double checking that number there. Yes, 29. So now these ones here are already given in the probability notation for us. So this is read male, given that they study Russian. So if we go back to our table again, I'm going to do some more rubbing out of these so I can see what I'm working with. Oops. So we're looking at male, given that they study Russian. So to start off with, we're just looking at our Russian group here. And then we're only interested in the males. So male, given that they study Russian, is going to be 14 out of 21. Next, Russian, given that they are male. So this time it's the other way around, which means that instead of having Russian as the group that we're looking at, the group that we're looking at is going to be the male group. So we're looking at the males, and of males, we are looking at those that study Russian. So this time, it's these 14 people out of all the males, which is 40. So that's our probability. Lastly, we're looking at the probability R given not male, so studying Russian given that they are female. So this time we're taking the bit that we're looking at as being the females. So we're looking at our group of females and we're wanting to have a look at the probability that they're studying Russian. So the only group that we're pretending exists is these 30 females here, and of those 30, 7 of them are studying Russian. So that's going to be 7 out of 30 as our probability. I'm going to give you a moment now to pause the video and give the Now You Try a go. So hopefully you've paused the video and given the Now You Try a go. So let's have a look through it. So last year, the employees of a firm either received no pay raise, a small pay raise, or a large pay raise. They are either paid weekly or monthly. Now this time we have not got the totals added to our table. So I'm going to start off by adding those on because it's going to make finding probabilities later on much easier. So my total for no pay raise is going to be 25, add 4, which gives me 29. For a small pay raise, that's going to be the 85 plus 8, which gives me 93. And for the large pay raise, that's 5, add 23, which gives me 28. Remember, you have a calculator in the exam, so you can use this to help you to add up. I'm also going to add up going across from my weekly paid and monthly paid. So we're going to have 25 plus 85 plus 5, which gives us 115 for weekly paid, and 4 plus 8 plus 23 for our monthly paid, which gives us 35. I'm also going to figure out a total, and there's a good way that we can double check this. If I first of all add up the pay rises, so the no pay rise, the small pay rise, and the large pay rise, I get 150. And I can quickly double check this by adding up the weekly pay and the monthly pay, which also gives me 150. So that tells me that I've done both of these probably correctly because they added up to give me the same total. Again, we've been given some notation to use. So D is the event that their weekly paid employee is selected. So probability of D is weekly, which means probability of D dash is going to be monthly pay. E is the event that the employee received no pay rise. So PE is no pay rise. And again, because we have two groups that are not PE, we could say that PE this time means, sorry, P not E, is some pay rise. And that's going to be combining together the small or the large. So it could be representing either of those put together. So, working through the questions, we have probability of D. So that means that we're looking at D is weekly, so we're looking at weekly pay, which means that we have our 115 here out of the total of 150. So that's going to be 115 out of 150. For the next one, P not E, we have to be a little bit more careful because, as we said just previously, not E is meaning some sort of pay rise. So we're not just looking at the total for the small pay rise, we're also looking at the total for the large pay rise. So that means that in total we have 93 plus 28, which gives us 221 people that received some form of pay rise, and that's what not E is representing. So that means that we have 121 out of our 150 people that got some form of pay rise. Next, we're looking at D or E, so we're looking at weekly pay, which is these people here, or E, which is that they got no pay rise, or both. And just as we saw before in the example, this 25 here is being counted twice. So we have to be careful when we're adding our numbers together that we're just adding 4, 25, 85 and 5 together, which should give us 119. And that is 119 out of our total of 150. Going to rub this bit off here. So next we're looking at E and D. So we're looking at no pay rise and weekly paid. So we're just looking at these 25 people here. So that's going to be 25 out of our total of 150. Next, we have D and not E. So that means that we're looking at weekly pay and they got some form of pay rise. So weekly paid, we're not looking at these 25 people anymore. We're going to be looking at these 85 here and these 5 here because they got some form of pay rise, which means in total we have 90 people we have 90 people, quite sure why my pen's got a bit weird now, out of 150. Next we have E or not D. So being in the E category means that you got no pay rise. So we're looking, E is no pay rise. So we're looking at the no pay rise column. Or not D. And remember that not D means that we're looking at monthly. And just as we did before, we have to be careful because this 4 here is being included twice. So we are going to have to do 25 plus 4 plus 8 plus 23, which should give us 60. So we should get 60 out of 150. Next, we're looking at the probability that a weekly paid employee is selected given that they have no pay rise. So if we were writing that to be in the probability notation, we'd be looking at the probability that they're getting weekly pay, so that's D, given that they have no pay rise. No pay rise is E. Just as we had in our example, just rub some of this bit out to make it a bit easier to see. Just as we had in the example, we're only looking at E. E is now our entire population, which is no pay rise. So we're only looking at these 29 people here. Of those 29, we're interested in D, which is our weekly paid employees, which is these 25 here. So that gives us a probability of 25 out of 29. Next, we have the probability that a weekly paid employee is not selected given that they received no pay rise. So we're looking at the probability that they are not weekly, so that's going to be D dash, given that they have no pay rise, which is E. And that's the same as this next question here. So we're just going to do this once because these two are the same. So this time, we're still looking at our no pay rise category. So we're still looking at this section here, but this time we're looking at a weekly paid employee is not selected. So that means that they must receive monthly pay, which means it's going to be 4 out of the total of 29. So that's going to be 4 out of 29. And as I said, that's the same as this question here. Next, we have the probability of not D given not E. So that's going to mean the probability that they are on monthly pay given that they received some form of pay rise. So if they received some form of pay rise, then that means that we're looking at these two sections here. So we're ignoring the people that received no pay rise, and we're now pretending that this pink bit here is the only bit that exists. We're then looking at people that are not on weekly pay. So we're looking at our monthly pay, which is these people here. So that means that we have 23 add 8, which gives us 31, out of 93 plus 28, which gives us 121. Whoops, I've already put that in my calculator there. So that means that we're going to have 31 out of our 121, which is all the people that got some form of pay rise. So that's 31 out of 121. Next, we'll be moving on to looking at Venn diagrams. Thank you very much for listening.